Hello everyone, I'm Mr. Moyavi, one of your grade 12 advanced maths teachers. In our last lesson, we talked about maxima and minima. In today's lesson, we'll talk about the product, quotient, and chain rules to find the derivatives. Right, so as you can see, I've got the title here already, product, quotient, and chain rules to find the derivatives. Right, so we are going to look at, firstly we look at the product rule. Number one. Okay, what is a product? Okay, we know it's multiplication or the answer to multiplication. So if we have a function, y is a function that contains the product of two functions, let's say y is equal to u multiplied by v, then its derivative will be given by dy over dx, which is equal to the second function v multiplied by du over dx, which is the derivative of the first function, plus u multiplied by the derivative of the second function, which is dv over dx. Right, so this is your product rule. If given a function y equals u times v, and u and v are functions in terms of x. All right, so let's take a look at an example. If I have y is equal to, let's say, 2x plus 1 multiplied by, let's say, 3x squared. Right, as you can see, these two functions, there are two functions and they are multiplied together. Right, so how do we find a derivative? Again, we just have to simply plug in these two functions into this function or the formula. All right, so the derivative here will be equal to, okay, what's v here? V is the second function here, which is 3x squared, multiplied by the derivative of the first function. Du over dx is the derivative of the first function here. So what's the first function? It will be 2x. So the derivative of it will be just 2 by applying the rule for differentiation. Right, here we have addition. So plus u is the first function here. So u is 2x plus 1 multiplied by the derivative dv over dx is the second function, which is this one. So we say the derivative of this function will be actually 6x by applying the rule for differentiation. Right, the rest of the process is you just have to multiply and then collect items here. So 2 multiplied by 3x squared will be 6x squared plus 1 times 6 is 1 times 6x is 6x, 2x plus 6x. Therefore, finally, our simplified expression will be 6x squared plus 8x. Right, therefore, the derivative dy over dx of this function, which is a product function, is 6x squared plus 8x. Right, now we look at the second rule, the quotient rule. We know quotient is the answer to division. So when you see a fraction, then that is also a fraction. It's a quotient. So the quotient rule is this: if a function is of this form, y is equal to u divided by v, then the derivative will be dy over dx will be given by the second function, which is the function in the denominator, multiplied by the first derivative of the first function minus the first function multiplied by the derivative of the second function. That's dv over dx. And all divided by v squared, the second function squared. Right, so the quotient rule is this. If given a function y equals u divided by v, u and v are different functions in terms of x. So let's look at one example. If I have y is equal to the function 6x minus 1 divided by 2x squared, then this function is a quotient. So we say dy over dx of this function will be, again, what you need to do is we're going to plug in the functions in this formula that we have derived. So the second function here is 2x squared multiplied by the derivative of the first function is actually 6 minus, right? Minus u is this function 6x minus 1 multiplied by the derivative of the second function, which is this one, will be, the derivative of this will be 4x. Right, and then divided by, don't forget your last function at the bottom or in the denominator, it will be 2x squared again. Right, so the next part of our working out is to expand this one and collect like terms, which is the numerator. So 6 multiplied by 2x squared will be 12x squared. 4x minus 4x times this one, 6x, will be minus 24x squared. And then minus 4x multiplied by negative 1 gives us minus 4x. All divided by 2x squared. Right, so the next part is for us to collect like terms here. We have 12x squared minus 24x squared. It will be minus 12x squared minus 4x. All divided by 2x squared. Okay, so therefore the derivative of this function here will be equal to minus 12x squared minus 4x divided by 2x squared. You can simplify this one, but if you reach this part, then you can leave your answer as it is. All right, that is the example for quotient rule. Now we look at the third rule. The third rule is chain rule. Now, if we have a function that contains another function, we'll say a function of a function, or we say composite function. So if a function is of this form, all right, this g of x is a function that is contained in the function f. If you have a function like that, then the derivative of a function containing another function will be given by dy over du multiplied by du over dx. Right. If we are given an example, for example, let's say y is equal to 2x plus 5 raised to the power of, let's say, 3. Then this function is a function that contains another function or a composite function. So in order to differentiate this function, we will firstly let the function that is within the bracket equals u, or u is equal to, let u is equal to 2x plus 5. If we let u is equal to 2x plus 5, then the function here becomes y is equal to u raised to the power of 3. And so once we are done with this, we can now apply the chain rule here. So we'll say the derivative of the function here will be equal to dy over dx is equal to Okay, the first thing that we need to find is the dy over du, which is going to be the derivative of this function. All right, so the derivative of this function, applying the rule for differentiation, it will be, bring the 3 in front, 3u raised to the power of minus 1 here, it will be 2, and multiply by the derivative here, du over dx is basically the derivative of this function u. So the derivative of this function, 2x plus 5, is basically 2. Right, so the next part is to multiply 2 by 3. 3 times 2 is 6. U raised to the power of 2. Right, but u is initially 2x plus 5. So in our final answer, we have to resubstitute the 2x plus 5 for u. So 6 multiplied by 2x plus 5 raised to the power of 2. Right? Once you reach this part, then that is acceptable. So you can leave your answer as it is. So therefore, the answer or the derivative of this function here, what is it? Y equals 2x plus 5 raised to the power of 3 is this. Right, so this is the derivative of this function here using chain rule. Okay, so in today's lesson, what we have learned is the 3 different rules. If you see a function that contains a product of 2 functions, then we apply product rule. If you see a function that contains a division, then we apply quotient rule to differentiate that function. And if you see a function that contains another function, then we apply the chain rule to find the derivatives of the functions. Thank you. In our next lesson, we'll talk about differentiating or finding the derivative of a trig function. Thank you.